Hey, welcome back to the lecture. So now you have good idea about volatile keyword, and now let's try to use that in order to fix the issue with our code. So that is with our pin read example code, and we know that this application actually breaks when we activate the O2 optimization level. So when we were debugging this through disassembly, we came to know that the compiler has generated instructions where this code is executed only once. So processor is not reading this memory address again and again for every iteration in order to fetch the new value. So that's because compiler has done an optimization on this address. The compiler has assumed that the data at this memory location will never change. So, but now we have to tell the compiler that the data at this address can change unexpectedly. So that's why let's change the declaration of this pointer. So here we have to mention volatile. So now compiler will not optimize any read and write operations performed on this pointer. So that would solve this issue. But I said one thing while explaining the theory, that whenever you are accessing memory mapped peripheral registers, use volatile generously. So that's why let's use volatile everywhere. So for all these pointers, let's use volatile. Volatile for the data, not for the pointer, like this. So all these are actually pointing to memory mapped peripheral registers. So here as well. And this should fix the bug. And now let's try. So it compiled successfully, and now let's check the optimization level first. This is O2. That's correct. Now let's just debug this code. So now here you see it is now going to read the fresh value from the port A input data register. This should work now. So now let's try with optimization level, let's say 3. Yes, it works. You can see that the pin status is changing. So every time it is reading from this address. So that's how you just fixed a bug in the program using volatile. And in the next lecture, we'll see how to use volatile with the interrupt service routine.